Myself, Professor D.S. Rai, Professor, Department of Civil Engineering, BBD, ITM, Lucknow. We will take up a course KCE 076 Urban Transportation Planning. We will discuss today lecture 20, in which we will discuss trip distribution. We have already started trip distribution in lecture 19. References we have taken Chakravarti Partho and Das Animes, Principle of Transportation Engineering, Papacosta, CS and Prevendus, PD, Transportation Engineering and Planning, Kadiali and Lal, Principle and Practices of Highway Engineering. Some material have been taken from NEPTEL and some material have been taken from internet. Contents today we will discuss trip distribution, introduction, basic consideration, trip distribution matrices, method of trip distribution, growth factor method, uniform growth factor method, average growth factor method, deteriorate method and gravity method. So, trip distribution matrices, two types of matrices. One is a production attraction mean PA matrix and second is origin destination OD matrix. The production attraction format of the trip table should be converted into the origin destination format to get actual direction of the trip between TAZS. The production and attraction PA matrix has no directional meaning, means whatever the trip produced or attracted have no direction, does not reflect the real direction from the origin and destination, represents the trip ends from production and attraction point of view of a zone. Here we can see our origin destination required for directional traffic assignment matrix. This is a generation zone and this is the attraction zone. This is zone 1, 2, 3, 4 to n and the total, and this is the zone 1 to 4 up to j, means up to zone j and total of this one. So, as earlier we have discussed, we can make a matrix here G I will be equal to sum over I is equal to 1 to n T I j. And attraction A j will be equal to sum over j is equal to 1, I is equal to 1 to n T I j. So, this is the method by which we can prepare the matrix. Now, the conversion of PA matrix to OD matrix for directional traffic assignment, PA matrix must be converted to a OD matrix. The general formula for finding the cell element of OD matrix. From the cell element of PA matrix, we can get R T I j will be equal to lambda T I j plus 1 minus lambda T j I, means number of trip from production zone to attraction zone multiplied by lambda, this is the constant, and plus 1 minus lambda into trip from attraction zone to production zone. So, we can say T I j will be equal to lambda T I j plus 1 minus lambda T j I, or T j I will be lambda T j I plus 1 minus lambda T I j, where lambda will be equal to proportion of trip originating from the production zone. Now, come to the method of trip distribution. There are two methods. One is growth factor method and another is synthetic method. In growth factor method, there are uniform factor method, average factor method, deteriorate method, Frater method and furnace method. These are the different methods used as in the growth factor method. We will discuss some of them, then come to the synthetic model, in which there are gravity model, which includes singly constant model, and second is doubly constant model. Then another is opportunity model, in which we will discuss inverting opportunity model and competing opportunity model, and one another is also there, that is linear programming approach in the synthetic model. So, there are many methods used for forecasting the trip distribution. So, first we will discuss growth factor method. Growth factor method, the present travel pattern are projected to the horizon year by using growth factor, that is T I j is equal to a small t I j into E, where capital T I j is the design year trip from zone I to zone j. A small t I j is equal to observed base year trip from zone I to zone j. E is equal to growth factor, and this growth factor method are used in the urban planning for short term update. If the tenure of future forecast is a very short period, then this method could be used. Now, come to the uniform growth factor method. A single growth factor E is assumed for the entire area under study for predicting the future interzonal trip from one zone to another zone. The growth factor is calculated by dividing the future total number of trip ends expected in the study area for the design year by the total trip ends in the base year. The same value of E is used to calculate the future number of trips for each pair of zone, means one zone to another zone. So, there is each pair of zone. So, capital I j will be equal to a small I j into E. What is the disadvantage of uniform growth factor method? The assumption of a single growth rate for the entire area is not correct. because each zone will have its own unique rate of growth. Second, underestimates and the overestimates movement where present day development is limited and intense respectively. If the present trip moment between two zones is 0, means present rate, then the future trip moment between the same zone will also come out to be 0, which is impractical. So, these are the basic disadvantage of uniform growth factor method. Now, average growth factor method. This is the another growth factor method. Growth factor for each zone is calculated based on the average growth associated with both the origin and destination zones. So, capital Ij will be equal to T, a small t I j into E I plus E j divided by 2, means average of production zone and attraction zone. So, where E I will be equal to P I, capital P I by a small p I, which is equal to generated trip growth factor for zone I. E j is equal to attracted in zone j to a small a j, that is attracted trip growth factor for zone j. A small p I present generated trips for zone I. A j future attracted trip for zone j. A small a j present attracted trip for zone j. T I j is future trip from zone I to zone j. A small I j will be equal to present trip from zone I to zone j. After distribution is complete, the projected and the actual trip ends at zone I and zone j will not match, then we go for iteration. This has to be overcome by an iterative process using new E I and new E j calculated from E I is equal to P I by a small p I and capital J will be equal to capital J divided by a small j, where P I and A j are the total generation and attraction of zone I and j respectively, obtained from the first stage of distribution. The iteration is carried out till the growth factor approaches unity and the value balance within plus minus 1%. Disadvantage of average growth factor method. The multiplying factor has no real significance. Second, there is no explanation for the movement between zones and the factors causing the movements. Next, a large number of iteration is required. Next, if the present trip moment between two zones is 0, the future trip moment between the same also come out to be 0, which is practically impossible. Detroit method. It is an improved version of average growth factor method. if the growth factor for the zones and the average growth factor for the entire area are taken into account, the T I j will be equal to a small I j into capital I into capital J divided by E, that is the average, where E I and E j are generated and attracted trips growth factor for zone I and zone j respectively. E is the average growth factor for the entire study area. In this method, the sum of the vehicle trip obtained may not agree with the estimate developed under the future trip generation. Hence, a series of iteration is performed and as in the average growth factor method. Exception is that E is also iterated by computing the ratio of future vehicle trips in the urban area obtained from the estimate of future trips generated to the total future vehicle trips calculated in the urban area. Disadvantage of growth factor model. The present trip distribution matrix has to be obtained first. Large scale OD study with the high sampling size are needed so as to estimate the smaller zone to zone movement accurately. Absence of the measure of the travel impedance imply that the travel impedance will remain constant. Effect of changes in the travel pattern by construction of new facilities and new network is neglected. So, we have taken these growth factor method. Now, we switch over to synthetic method. Synthetic method attempts to discern the underlying cause of movement between places. Relationships are established between trips and measures of attraction, generation and travel resistance. Synthetic method can be used not only to predict future trip distribution, but also to synthesize the base year flow. Measures of travel resistance impedance, it may be in form of cost, in form of time, in form of distance. Impedance is resistance in travel between two zones. Travel distance, travel time, travel cost and travel utility are indicator of travel impedance, as I have told earlier. Travel distance, the further two zones are from each other, the less likely there will be interaction between them and viewers. Travel time. In real travel, travel time may vary by time of day, day of week and other factors. The difference in travel time can vary as much as 2 or 3 times between peak and off peak hours. Usually, only distance, however, these variations are never picked up because the distance between location is invariant. Travel cost, sometimes called generalized cost, incorporates real and perceived cost of travel between two locations. A more realistic model of incentive and disincentives to make a trip between two locations requires a complex function that weigh a number of factors affecting the cost of travel, and they are travel time, implicit operating cost, out pocket cost and perceived cost. Now, come to the next, that is utility, travel utility. Utility is an individual concept rather than a zonal one. Usually, higher cost is associated with less utility, but the utility of travel for an individual is a function of both real cost and a number of individual characteristics that affect the value placed on that travel. Two individuals living door to each other who travel to the same destination location may price their trip very differently. Now, come to the gravity model, which is widely used in trip distribution. As we know Newton's law of gravitation, where F is equal to F m1 into m2 divided by d square, where F is gravitational force acting between two objects, G is gravitational constant, m1 and m2 masses of the object, and d distance between the center of the masses. In gravity model, interchange of trip between zones is considered as a function of relative attraction between zones and a spatial separation between them. Function of a spatial separation adjusted the relative attraction of each zone for the ability, desire or necessity of trip makers to overcome the spatial separation. The main assumption of gravity model: the number of trips between two zones is directly proportional to the number of trip production at the origin zone and number of trip attraction at the destination zone. So, these are the proportional to the trip generation in the future, and this is inversely proportional to the travel resistance or travel impedance and that will be equal to capital T I j will be equal to alpha p capital P I into A j divided by d I j to the power n, where capital T I j is a trip between zone I and j, P I trip produced in zone I, A j trip attracted in zone j, d I j is equal to distance between zone I and zone j or time or cost of travelling between them. A is the constant and n is exponential constant whose value are usually found to lies between 1 and 3. So, gravity model, type of gravity model, singly constant models, production constant sum over j, capital T I j is equal to P I, capital P I. In attraction constraint sum over j, capital T I j is equal to capital A j. attraction in zone J. In doubly constant model, sum over J capital Tij is equal to Pi and sum over J Tij is equal to Aj. So, singly constant gravity models are Tij is equal to Pi into Aj into Fij into Sij divided by sum over j is equal to 1 to n into Aj into Fij into Sif Fij, where Tij is equal to trip produced in zone I and attracted in zone J, P trip produced in zone I, Aj trip attracted in zone J, Fij time factor, travel time factor which expresses the average area wide effect of a spatial separation of on trip interchange between zone I and zone J. Sij, a specific zone to zone adjustment factor to allow for the incorporation of the effect of the travel pattern of a definite social and economic linkage and that are not otherwise accounted for in the gravity model formulation, and n is the number of zones in the study area. Thank you much. Thank you very much.